So let's go for the fourth session for IPSEC. In this session, we're going to see IKEv1 RFCs, IKEv2 RFCs, and other RFCs that belong to IPSEC. So let's go for IKEv1 RFCs. The RFCs that make up IKEv1 are mainly these ones. So we have this RFC that is known as the domain of interpretation. In this RFC, we are going to provide actually numbers to parameters. So when numbering protocols, in this RFC, for instance, we can say that the ISAKMP protocol is the protocol number 1, that the authentication header protocol is protocol number 2, that the ESP protocol is number 3, for instance. We can also provide numbers for encryption algorithms. For instance, we can say that the DES encryption algorithm is number 1, that the AES encryption algorithm is number 2, and so on. So the same for hashing algorithms. So for instance, we can say that MD5 hashing algorithm is number 1, that the SHA-1 hashing algorithm is number 2, and so on. So this definition of numbering is established officially in this RFC. Now the ISAKMP RFC is very generic when it comes to defining processes. It does not go into detail. The only part when it goes to detail is when talking about the header. So we can say that the ISAKMP header is pretty much defined in detail in this RFC. So the other RFC, which is the IKEv1 RFC, goes into detail for several processes that are not detailed in the ISAKMP RFC. So for instance, in the IKEv1 RFC, we can see the definition of how phase 1 main mode works, how the phase 2 quick mode works, and so on. So as time went by, the IKEv1 RFC started to show several issues. So several other RFC had to be created in order to become patches for IKEv1. So we have the NAT traversal patch, the certificate authority list patch, the dead peer detection patch, and so on. So given these are patches that are not included, these features are not included in IKEv1, these are just optional features for vendors. So one vendor can support IKEv1 but may not support exchanging certificate authority list. Another vendor may support IKEv1 but may not support dead peer detection. Another vendor may support IKEv1 but may not support NAT traversal, and so on. So these particular features become optional. So let's see these RFCs in more detail. So for instance, ISAKMP talks about several processes in a very generic manner, not going into detail. So for instance, it talks about phase 1 and phase 2, but it doesn't go into any detail at all. But however, when talking about the ISAKMP header and the payloads, it goes into a very deep detail. So this is one of the examples with this ISAKMP RFC goes into detail. Now, if we examine the IKEv1 RFC, we can see that it goes into details of several mechanisms. For instance, it defines phase 1 main mode, phase 2 quick mode. It defines key exchanges using Oakley groups, and so on. So it goes into more detail than ISAKMP does. So we can, for instance, see this RFC that details what encryption algorithms and hashing algorithms can be used with IKEv1. And we have the domain of interpretation RFC that assign numbers for protocols assign numbers for encryption algorithms, assign numbers to hashing algorithms, and so on. So there is this particular RFC, which is RFC 9395, that defines the end of life of IKEv version 1. It is the official declaration that we should not use IKEv version 1 anymore. The development for IKEv version 1 ceased over a decade ago. That means that it ceased about 2013, because this RFC was released on 2023. And this is a risk. And there are vendors that will not be providing any more features for IKEv version 1. The implementation is frozen for IKEv version 1. So you should be aware of that. IKEv version 1 is no longer secure. You should migrate IKEv version 1 configurations to IKEv version 2. Now, regarding IKEv version 2, the whole set of features included in IKEv version 2, or most of them, are defined in a single monolithic RFC. This RFC was updated over time, so the most current one is this one. However, there are other RFCs that are being released more recently. For instance, we have this cryptographic recommendation for IKEv version 2. We have this more recent recommendation of using quantum cryptography for IKEv version 2, for instance. And if we go and read the RFC, we can see that it is quite detailed. For instance, it defines the usage of NAT traversal. It defines the usage of dead peer detection packets. It actually goes and redefine the header for phase 1, so we can call that now the IKE header rather than the ISAKMP header. And there are other RFCs out there that, for instance, for IKEv version 2, recommend the usage of some encryption algorithms, and recommend not using all the encryption algorithms. They recommend using some hashing algorithms and not using some old hashing algorithms. The same for some Diffie-Hellman groups. It recommends using some of them and recommends not using some others. And we have other set of IPSEC RFCs. So for instance, for the authentication header, it was first defined in this RFC that was updated over time. For the ESP header, it was first defined here and it was updated over time. So this is the summary of what we saw for IKEv version 1. For what we now know as IKEv version 1, it is defined in several RFCs. The domain of interpretation RFC that defines actual numerical values for parameters. The ISAKMP RFC that mainly defines the control packet header payloads. And the other thing that it talks about are pretty generic, but and the IKEv version 1 actually goes into details of several mechanisms for instance, phase 1 and phase 2 processes. And for IKEv version 2, it is actually defined in a solid, pretty robust RFC that has been updated over time. There are other RFCs that are complementing IKEv version 2, but the IKEv version 2 RFC itself is pretty much monolithic and complete. And we have many other IPSEC related RFCs, for instance, the authentication header RFCs or the ESP RFCs. That's it.